Hi, I'm Bharat Kumar, and I'm going to talk on my project topic for the Marketing 830 on changing product dynamics, creating value in industrial automation. With extensive background on industrial automation working at ABB, I wanted to cover certain concepts learned in the marketing class to correlate with my real-time work experience. My focus will be on product management portfolio of industrial automation products and how various decisions are made to reflect customer expectations, which in turn shape the product development in the sector. I want to apply learned concepts on BCG matrix, product life cycle, and some of the product benefits to customers like augmented and potential layer. Introduction. In introduction, I want to briefly cover what is industrial automation in context and how it fits in overall equation. Industrial automation can be defined as the use of control systems and software to independently operate and monitor a system of industrial processes. It is distinguished between two primary types of automation: factory automation and process automation. Factory automation tends to be used in manufacturing facilities where component parts are assembled and incorporated into a larger, more complex units or a final product. It is therefore associated with industries such as automotive and packaging. Process automation is used in industrial sites such as chemical or power, where a continuous flow of, say, water or oil is being monitored, controlled. In terms of products, DCS, which stands for Distributed Control Systems, valves, and other flow instruments, are primarily found in process plants. Drives, robots, and PLC, which stands for Programmable Logic Controller, are more common in factories and are products used in discrete automation. I choose this exhibit to represent human beings' continuous thought process to invent and reinvent the technological ideas in hardware and software to provide betterment to society. Key insights. Industrial automation is a growing industry worldwide. According to Sandler Research, the global market for industrial automation is growing at a compound annual growth rate of 6.87% through 2018. The end market value of industrial automation in terms of revenue is worth more than $150 billion annually, divided almost evenly between factory automation and process automation. Increased pace of digitization. Digitization is a new driving force behind industrial automation and is creating a situation and new reality in which the strategic control points within the automation and digital manufacturing industry are shifting towards software platform-based business models. Lots of system architecture models, which involves both hardware and software, are constantly changing, and virtualization is playing a big role in minimizing hardware. In previous model setups, there were a lot of server-grade computers and hardware used to run the core functions for control system, but today lots of them are virtualized and fewer physical servers and hardwares are needed to run the same setup. In this exhibit of BCG Matrix, a framework created by Boston Consulting Group to evaluate the strategic position of the business brand portfolio and its potential, it classifies business portfolio into 4 categories based on industry attractiveness, that is market growth rate of that industry, and competitive position, which is relative market share. These 2 dimensions reveal likely profitability of the business portfolio in terms of cash needed to support that unit and cash generated by it. The general purpose of the analysis is to help understand which brands in the firm should invest in and which ones should be divested. From industrial automation perspective, small relative market share and fast growth rate, which is question mark quadrant. The products in this quadrant are 3D printing, and wireless connected enterprise, which eventually will save huge cost in infrastructures for customer, hence will be very demanding product in near future. But since we are in growth phase, we still don't know the full potentials yet. Some industry like aerospace have already started using some of the products from 3D printing in their models. Relatively large market share and fast growth rate are star products. In automation, it's robotics, as a lot of manufacturing industries are moving in this direction to efficiently run the plants with relevant cost saving for customers. Manufacturers in many industries have long used robots to tackle complex assignments, but robots are evolving for even greater utility. They are becoming more autonomous, flexible, and cooperative. Now they can interact with one another and work safely side by side with humans and learn from them. These robots will cost less and have a greater range of capabilities than those used in manufacturing today. The cash cow product, which has relatively large market share but slowing growth rate, are controllers and drives, which are still in demand and extensively used in automation sector, but there has been already development of virtual controller products which will soon replace this product, as those new products are software based and will come eventually at better price points. The dog product has relatively small market share and slow growth rate. In this case, it's power grid automation, for which I have shown an image of a tower, which are in decline with overall decline in demand for utility sector because of market saturation. To explain this case, ABB has sold off its power grid business to Hitachi because of a declining business for ABB in the utility sector. But for Hitachi, it's a complement offering in its product line to further solidify its footprint in electrification business. So a dog product for one company can still be a star product for the another. Trends and challenges. In this slide, I have captured some of the trends which are redefining how automation are adapting and meeting their customer needs. With disruptive technologies, organization transformation towards flexibility, and evolving customized customer demands, which in turn shapes the various product lifecycle demands. Here, to showcase this aspect, I have taken products in industrial automation and mapped them to different phases in the product lifecycle. Raymond Vernon came up with a product lifecycle theory where he describes number of steps that each product goes through as it penetrates the market. These steps include the initial research, sales growth, maturing of market demand, and ultimately the product's decline. The introduction phase in the period where a new product is first introduced into the market, these typically requires a lot of resources and finances. In automation world, the introductory products prevalent into today's market are 3D printing, digitization, and analytics, wireless connected enterprise. The growth phase is when product starts to sell at a much faster rate. The public is becoming increasingly aware of the product and word of mouth is starting to spread. The product's capabilities are now recognized and the product development has matured, which means the rate at which you are changing your offering slows. Robotics and control system technology will fall under this category in industrial automation as they are popular and more industries are utilizing it to optimize and improve efficiency in the plant's operation, and these products are a hot sell. The maturity phase is when the product sale begin to peak. Demand is strong. Very soon the products will begin to compete with new alternatives being introduced into the market. Controllers and drives products in industrial automation will fall under this category. The decline phase refers to the period when the product reaches its saturation point. In this case, the price can start increasing though the number of sales will decline. In this phase, a decision is needed whether to continue with the product with significant changes or to move on to another product altogether or divest, like in this case of product grid automation products. Also, I tried to overlap the BCG matrix on product life cycle, depicting the question mark, star, cash cow, and the dog products. Present and future automation stack. Theodore Levitt has described 4 different layers of product to be considered when it comes to product benefits, which are generic product, which refers to features needed to deliver the core benefit of the product. Expected product, which is generic product plus the minimum the customer expects from the product in that category. Augmented product, which goes beyond the expected product to include unexpected value enhancing elements. Potential product is an extension to the augmented product that includes everything that might be done to attract and retain customers. Today, only some of the industry manufacturers have sensors and machines which are networked and make use of embedded computing. They are typically organized in vertical automation pyramid in which sensors and field devices which limited intelligence and automation controllers feed into manufacturing process control system. But with the industrial Internet of Things, more devices, sometimes including even unfinished products, will be enriched with embedded computing and connected using standard technologies. These allows field devices to communicate and interact both with one another with more centralized controllers as necessary. It also decentralizes analytics and decision making, enabling real-time responses. The term open automation, which has been emerging because of IoT enhancements, is new generation of automation system, which with a distinctively different architecture than the programmable logic controllers that are used today for manufacturing automation. This is a perfect example depicting the augmented product in the product benefit to customers where the whole channel of programmable logic controller can be bypassed and the field devices can directly communicate to software platforms, which in future will result in elimination of a hardware layer, resulting in huge cost saving to customers. Strategic control point. Digitization have the potential to change the fundamental structure of the industry. Strategic control points that have long been owned by specific market participants are now in play, creating the potential to shift in traditional value pools. Companies have just begun to adopt additive manufacturing like 3D printing, which they use mostly to prototype and produce individual components. With Industry 4.0, these additive manufacturing methods will be widely used to produce small batches of customized products that offer construction advantages such as complex lightweight designs. High performance decentralized additive manufacturing system which will reduce transport distances and stock on hand. This value creation for customer segment will push this product to potential layer as it far surpasses the expectation level and creating a brand new business venue compared to traditional firms. Conclusion. There is a near unanimous agreement that the trends of the shifting growth pattern and digitization will dramatically disrupt the ecosystem of the industrial automation sector, and little dispute over the forecast that the ownership of the strategic control points will change hands and value pools will shift. That said, there are a set of principles that all marketing managers can commit to in order to prepare for this radically different future. Target relevant value. Target the most attractive opportunities out there to invest mainly in IoT, digital business building that is most relevant, not the most popular. Build on distinctive strengths. Tackle the opportunities that align with company strength and that is in the natural position to own, or at least position to be competitive in. Focus on the core. Build a strategy that is robust against attacks from increasing competition and against economic downturns by emphasizing and optimizing the core business. Hope you enjoyed my presentation. Thank you.